COVID-19 poses challenges to healthcare workers, policymakers, and the general population, unlike any seen since perhaps the influenza pandemic of the early 20th century. Humanity is now more mobile than ever, and for the first time in history, more people lived in cities than in rural locations. And this novel coronavirus is taking complete advantage of all of this. Despite the monumental challenges that this pandemic poses, we have tools we've never had before. There have been enormous advances in infectious diseases research, treatment. Instant global communication is commonplace, and with artificial intelligence and personal technology, we may have the ability to track how patients develop symptoms, or if they will at all.
The science is moving at a pace that I've never seen. Everything from the structural biology of the virus and the antibodies to the virus from patients to design drugs and vaccines and neutralizing antibodies. And it's actually extraordinary. What we're stuck with is how can we find people where there's going to be a cluster or an emerging outbreak before it spreads more?
The question now, will this new tech make a difference? And if it will the people want it?
The issue, of course, is getting people to be citizen scientists. You don't need everyone in the country to be a citizen scientist. You just need enough.
This is Medicine in the Machine, an information and conversational podcast about how technology is impacting medicine right now and how it will in the future, featuring Dr. Abraham Verghese and Dr. Eric Topol. I'm a producer on the show, Nick Andrews. In this episode, the hosts of Medicine in the Machine talk about this new tech, where the research is and what the thinking is, as well as what can be on the way in the fight against COVID-19.
Welcome, everyone, to this episode of Medicine and the Machine. I'm Abraham Verghese from Stanford University, and it's my great pleasure to co-host this with my friend and colleague at Scripps, Eric Topol. I'm really excited about the topic today because we really are talking about something that has been a great interest of Eric's well before COVID, and we're seeing this wonderful convergence of the kind of technologies, wearable technologies, AI, that have the ability now to predict disease in a way that is particularly meaningful in this COVID epidemic. So, Eric, welcome to this episode. So nice to be doing this with you.
Oh, same here, Abraham. It's always a pleasure. And, we have a great topic here because here we're trying to use technology as an edge to deal with this whole COVID affair. And we're struggling, no question. Everybody talks about testing. But we know those tests have issues. One, of course, there's false negatives for the virus or the antigen test. And there's also logistical issues of doing them at scale. Some point we're hoping for home tests, not just home kits, but we're not there yet and at least a few months away. And also, there's an expense, there's a time limitation because they're one-off tests. So it's interesting that the first thing that people turned to was taking temperature checks. So I don't know about at Stanford, but here at Scripps Research, you have to if you want to go onto the campus, you have to have a temperature check. And the people working in the labs, all are going in every day. But, that's so silly because as it turns out, there's been multiple prospective studies about fever and COVID-19. And in the big one published in Nature Medicine, it was about 30% of people had a fever. And then the one that was just published by Color Genomics was 12%. So
wow.
Most people don't have fever if you look at it prospectively. And also they could be pre-symptomatic and asymptomatic. We know the asymptomatic is at least 30, 40%, and then the pre-symptomatic people actually shed and are infectious at least as much, if not more. So this whole notion that it's like a placebo, I don't know what you think about the temperature checks.
No, I quite agree with you. I think we learned too late that we didn't emphasize masks enough. We overemphasized temperature measurements. Before we dive in deep, I think it's worth reflecting how different this is in terms of where we are in science compared to, say, the HIV era, where we operated for a couple of years not even knowing the cause of that disease. and then many more years without having effective therapy. Or, for example, the 1917 influenza epidemic. And here with this epidemic, we've been able to sequence the genome of this virus within weeks. I'm just astounded at the science. And the only way I keep up with it, frankly, Eric, is by following your tweets, which are really right at the cutting edge of everything that's coming out. And so I wanted to maybe start by asking you about the wearables, because I think this is, following up on the temperature story, it's clear that is coming much too late. And there's a whole explosion of wearables that preceded COVID, but now are turning their attention in big research consortiums of which you're a part, to alerting us to people being ill before they actually know they're ill.
Right. Well, first, thanks on your point about the science is moving at a pace that I've never seen. Everything from the structural biology of the virus and the antibodies to the virus from patients to design drugs and vaccines and neutralizing antibodies. And as you said, the sequence to trace it both temporally and spatially, geographically throughout the world. I mean, it's actually extraordinary. But what we're stuck with is clearly how can we find people where there's going to be a cluster or an emerging outbreak before it spreads more? Because we know now the famous Pareto rule or principle, about 80% comes from the 20% or 90% comes from the 10%. So the issue here is if we could find these spreading events early and concentrate on that, because we can't test everybody, every day or every week, then that would be a nice way to get our arms around it, because we're so far behind in the U.S. And some other countries as well. So here is the opportunity to use, as you say, sensors that get continuous data, and that would give us an edge. And I think, we have started one project, Detect, in March, now have about 38,000 participants. There are others with a ring and other. Ours is with a smartwatch or fitness band. It's called Detect. And what we already have, interesting in the first 30,000 people, is that we saw a signal correlating with not just symptoms, but positive tests based on resting heart rate that is going up, more sleep, and less steps. And those three sensor measurements were a signal. And what we also have noted, and interesting, Abraham, because we had done work with the flu-like illness showing that same sort of signal that we could detect very rapidly. But Germany read our paper in Lancet Digital Health in January, and they started their own smartwatch app. They have over 500,000 citizens using it. And China, similarly, now they have 1.3 million people using it. So we know that these outbreaks are going to keep occurring. And just when you think, like, for example, as you saw in Beijing, this 55 days with not a single case, and then now, hundreds of cases. And so it's really imperative that we come up with a continuous surveillance signal. And the confusing thing is people are conflating this surveillance tool, digital tool, like heart rate or body temperature, those sorts of things, with the contact tracing apps, which are very different, which haven't been validated in any way, that are very controversial.
Yeah, to come back to the scale of this is just unimaginable. The fact that you can have so many thousand people in a study in such a short time. I guess it begs two questions. One is, has this been vetted sort of with the same academic rigor we bring to other trials? And secondly, do we get the signal early enough to make a difference in some way?
Right. Well, we have to validate that. We only have done that for flu-like illness in about 50,000 people using Fitbit. And we saw the signal was well before the CDC had detected flu-like illness. So this is a different matter. But in many ways, Abraham, it's even more conducive. And the reason I say that is because there's so many people asymptomatic. And, let's say at least a third that never have symptoms all the way through their infection. But we now know from 4 different series of lung CT scans in these people, from the Diamond Princess ship and from Korea, it's really striking to see that more than half have lung CT abnormalities, ground glass opacities, and consolidations that are just the same as the people with COVID-19 and have symptoms. Wow. So what's striking is they are having internal hits churning in their body, and you would expect things like the heart rate to help pick that up. Mm-hmm. The other thing is that pre-symptomatic phase, because we know that, and again, the resting heart rate goes up before the fever is manifest. And a lot of people never have fever, as already mentioned. So, we think that sensors, and the other striking thing is in the U.S., over 100 million people have a wrist sensor for heart rate. So it's just widely out there. It doesn't cost anything to wear it. Most people already are wearing it. So, we think that could be a good way. But as you say, Abraham, it has to be fully validated for this specific virus, which parenthetically is the worst pandemic in over 100 years. So, hopefully we can find ways, not just testing, because that's going to always be a one-off, even when we have a home test, which we'll eventually see, that's going to be something you could do. It's going to be at least $10, $20 or more each time you do it. And it's for that day. So we need something that, got to have a lot more temporal bandwidth so you can see what's going on in people. It's not so much helpful in an individual, that if your heart rate goes up, you don't know. But if it's in your neighborhood, if it's, a cluster, that makes it much more of a real signal.
I'm sure the listener is curious as I am, as someone who uses one of these devices. Can I tell, or do I have to wait for the research consortium or the meta gatherer of all this information to let me know that I'm about to do something?
Right. Well, I think the way it's set up, and we're seeing this now, in Germany and in China, hopefully we'll see it in the U.S. When you have a surveillance tool like this, you get a signal. Right now, what we would do is, go in and offer testing, tracing, isolation. So it's a gateway to precision testing, because then something may be going on there. You don't know for sure. It could be a false positive signal. And that's the way it would proceed. But, in the future, by hopefully later in this year, we could get home tests to those people where there's a signal to find out quickly, because that hopefully will be done, in a matter of minutes once the test is in a person's home. So, it's just the beginning to get more precise testing, and then, leave it to local public health, the contact tracers to activate. And, that's something that since we're in the early stages in the U.S., we're behind other countries in this. Hopefully we'll be able to mobilize, because as you know, we have a limited number of people, human contact tracers, which is kind of ironic since we have such high unemployment. Why don't we recruit? The other thing that's funny about this, Abraham, is, it's kind of like the Rodney Dangerfield, this whole digital thing. When I worked with the Rockefeller Foundation National Action Plan, had a panel of 20 plus, experts, Paul Romer and all these, people, Nobel laureates, and all the sessions were about how many tests we should do each day. How many tests? 1 million, 5 million, 10 million in the U.S. And I'm like the carnival barker saying, well, what about digital? And finally, in the report, digital was recommended, but it doesn't get the regard. And the issue, of course, is getting people to be citizen scientists. Turns out a lot of people like to get their data, and as you said, like to get a notification that something in their neighborhood is showing a potential signal without inducing anxiety, but at least raising awareness. So hopefully we can ride that. You don't need everyone in the country to be a citizen scientist. You just need enough. We have every state covered, but not densely enough now. And that's something that's going to be important.
So I have two thoughts that come to mind as we talk about this. One is the issue of equity and access. I mean, this has been such a earth-shaking moment in our country's history, ever since the first slave ships landed here in I think in the 1600s. We've finally come to terms with this. So with the mass deployment of these devices, how do we ensure that we truly are studying a representative cross-section of this country, and that, everyone has equal access to what is basically a public health measure? But the flip side of that is the whole notion of privacy, and our resistance to having Big Brother watching over us too much. How do we wed both those different things?
Yeah, and those are critical questions and points. So, on the one hand, the U.S. has a terrible situation with its inequities, which has been brought out by the pandemic. And so already before it came here, we were the only, country, developed country in the world that wasn't giving all people, all citizens, health care. So now that the pandemic invaded, we've seen the toll it has taken, and it's profound. And the people who have suffered the most are those who are underrepresented minorities and the indigent. And it's really, horrendous situation. Now, with respect to the ability to do tracking, fortunately, our project and others like it are ones that are dedicated to this end only. The data will never be used for any other purpose. It's part of the informed consent. But also, you don't need people that don't have a smartphone or a smart watch or a fitness band. It's okay, because what's going to happen here is that it's just like the traffic map that you look at on Google or Waze. If there's enough smartphones chirping to give you a map, you don't have to have every car to know that there's a big traffic jam or that traffic is running smoothly. So we just need enough to get some coverage. And so thereby the people who don't have this technology would still derive the benefit of knowing there's an outbreak potential in their area. But, we have a problem, because people who are in these underrepresented minorities and lower socioeconomic status, they don't have access to testing. They aren't looked after. They're afraid to come in. Many of them are afraid to come in because they could be deported, or who knows what could happen to them. Mm-hmm. So we have a lot of collateral damage from the pandemic here because of our just so tenuous and in many ways pathetic framework of healthcare.
Stay with us. We'll be right back with Medicine and the Machine.
You can read the transcript from this podcast and find more Medicine and the Machine episodes at medscape.com/machine. Medscape news, features, clinical tools, and education are available for free. Stay on the pulse of medicine. Visit medscape.com.
I want to switch gears, if I may, to, again, something that you've been tremendously interested in for some time now. It's been the subject of your books as well, and that is AI. I mean, I want to remind our listeners that an AI company, Blue Dot, in Toronto, was the first to spot the unusual cluster of pneumonia cases in Wuhan.
Right.
And I think AI has gone on to have incredible applications here, not just epidemiologically, but in terms of molecular targeting. And I'm learning a lot of this by listening to your Twitter feeds or reading them. So talk a little bit about that, about how AI has been brought to bear on this problem.
Right. Well, certainly analyzing the data that I've already mentioned, getting in tens of thousands, if not millions of people's continuous data requires deep neural networks to analyze that data. So that's one use of AI. And as you mentioned, that Blue Dot company that was profiled in 60 Minutes was onto this, well before the U.S. They had so many different layers of data that they were continuously analyzing in China, not knowing there'd be a potential pandemic, but just that something was going off the track there. they had a baseline, and they could see through many different means, including things like, the hospitals starting to change in their parking lots and, all sorts of digital indirect things. But you added these different points together, you knew that there was something that was definitely wrong. And the U.S. wasn't a part of that. But interestingly, California, our governor, was in touch with Blue Dot, Governor Newsom, and he got one of the reasons why it was the first state to go into a lockdown, shelter at home, stay at home status was because of that early warning. But, if that's just one idea of being able to be knowing where a pandemic is going, where it's starting, the timing, geographic sort of thing, but other things that you've touched on. We are seeing several drug programs that are being catalyzed by AI, whether it's mining lots of data that's already existing from SARS-CoV-1 or other coronaviruses, MERS, or just the structure of the virus or the antibodies with the epitopes. All these things are leading to a much more accelerated candidate drugs, candidate vaccines, and neutralizing antibodies. So that's another part of AI. Now, the one that I'm interested in your views, because it then brings in the human expert oversight, the human in the loop, and the machine, is the prediction of people who should be in the hospital versus the ones who should stay home. And this is an interesting dilemma, because there's a company, at least one that I'm aware of. There's one called Current Health, and it has this thing you put on your arm, and it has everything but blood pressure. It has heart rate, and it has oxygen and body temperature and respiratory rate. It gets through the sensors, and it can transmit that to the medical facility. And it claims, and several health systems are using it, not ours, and I doubt it's Stanford, but many health systems are using it to keep people at home, which is a good idea, and prevent them having to come into the hospital, giving them continuous monitoring with algorithms to analyze that data with an alert if there's something that is starting to go off track. But it hasn't been validated. What are your thoughts about that?
Well, I think I've been humbled by one of the early AI studies that I'm sure you will recall, which showed that we were miserable about predicting 30-day mortality in our patients. We were really terrible about prognosticating and recommending chemotherapy because we had no good sense of how much longer a patient had, and the machine clearly could do a lot better than us. So I'm for this. I think with any data like this, as you know, I think we need to have continuous clinical input and monitoring, and have the data be available for validation by other groups rather than blindly applied, which, as you know, can result in amplification of all kinds of injustices and mistakes. So I mean, maybe this is a good moment to also ask. I mean, we're talking about artificial intelligence in the face of the great dearth of the kinds of social intelligence, the kinds of administrative intelligence that would be required for a crisis like this. To politicize this virus in quite this way is extraordinary. But on the other hand, I've been, rereading a lot of the plague literature, whether it's Camus' The Plague or, the Decameron or any number of plague narratives. And I think we have to understand that this is very much the nature of human beings. There is the cognitive intelligence side, and then there's the emotional side. And in many ways, that is the problem, is wedding science with humans' abilities to undermine all good science and all good public health measures. And I mean, I wonder if we could turn AI into figuring out how to help us with the sort of moral, social choices that are, I think, undermining everything that medicine can do.
Yeah, it's going to take a challenge there, because that's the part that we, as humans, should be doing much better. and we're not. And whether we can get that supported in some way, bolstered through this, algorithmic means, it remains to be seen. But yeah, I mean, I am really struck by the complexity here that isn't adequately appreciated. So, for example, you mentioned the not respecting masks in the beginning, and still 1 out of 2 Americans are not wearing a mask, which is shocking. We can't even get that straight. What is the big deal about using, any sort of face covering to help reduce the spread? So we don't have a social contract. That it's like a vaccine where it only works if, everybody's doing this. And we have kind of the anti-mask movement like the anti-vax movement. And I don't think any algorithms are going to solve that one. That's the problem. And then we have these crazy things that have happened whereby, this was thought to be a lung disease. And then we realized, well, you know what? This virus likes ACE2 wherever it is, and it will attack the heart and simulate a heart attack. It will attack the kidneys, even on an isolated basis, or it can attack the brain. I mean, anywhere there's ACE2, in fact, even new onset diabetes, because the pancreas islet cells have rich ACE2 expression. So, the complexity here hasn't been fully appreciated. The other thing, which is of great concern, is the chronicity. So many people, they get out of the hospital and they may even have had, long intubation, oftentimes, as you've seen, a couple of weeks or more, 3 weeks, and they're well enough to go home, and they don't even have to be that sick, but they have chronic problems, chronic fatigue, chronic difficulty breathing, and we don't understand that. And we don't even know the natural history of that. I don't know if you've had patients asking you, is this going to go away? And, it's really a concern that we don't understand this. There's this peculiar immune secondary wave that we see, for example, in children, where they have this Kawasaki-like disease. It's not Kawasaki. And it could be even after they recover and they get pan-body, multi-system inflammatory organ involvement. So, I just think that we haven't yet appreciated the full hit here. We have tried to simplify it, and it just hasn't gotten us too far. We have to, the asymptomatic thing is another one. That's like in the iceberg, below the surface. And the science community was in denialism. That is, they said, oh, well, it can't be 30% or 40%. It's just not possible. We've never seen a virus that has 30 or 40% asymptomatic and then can be a killer. That spectrum. But it turns out it's easily 30%. Now, that denialism shouldn't be the norm when you are seeing something that's never been seen before. But we tend to get, entrenched in our priors. And, it's interesting. I feel like we're learning every day about this, horrendous virus and its toll and in so many different dimensions.
I think the exciting thing, the good news in the midst of so much misery is that, we've seen a jumpstart of science. We've seen a jumpstart of AI. We've seen a tremendous boost to wearables and this new application, big consortiums coming together. Google has bought Fitbit and so on. And I think that is the nice silver lining of this very, very dark cloud. I think the challenge remains, and perhaps that's appropriate for our podcast, the challenge remains to communicate the elegance of the science, the clear solutions to the public in a way that is not politicized and penetrates and gets through. And I think that's on us. I think that's on us in science to find clearer, better ways to communicate. I'd like to think that people will put their health before anything else, but right now it doesn't quite seem that way. But as we wind down, Eric, I wanted to ask you, as you look ahead at the frontier of digital technology, science, wearables, AI, what are some things that you're looking to? Where do you see light at the end of this tunnel?
Well, before going into the clear positive things, I would just say that, there's been a lot of hope for this contact tracing, that we don't have enough people doing this. It's an arduous task to contact people and tell them that they've been exposed and, go forward and backward contact tracing. It's quite laborious. We don't have enough people. So the idea was that we would have apps that would be picking up smartphone signals and alerting people. But as it turns out, we don't know if that's going to work, because where it's been tested in Singapore and Norway and many countries, there hasn't been enough participation. You need it. It's kind of like herd immunity. You need to get, 60, 70, 80% of the population to use it. Plus, there's issues about privacy, for sure. There's, ethical issues and false positives and all sorts of things. So it hasn't been validated. So that's one that is out there dangling. We need it if it works and if people would accept it, but it may not ever fly. And that remains to be resolved. Now, on the positive front, I think we will get through this. It's going to be a long haul, though. There probably will be a vaccine. What's fascinating about this virus is how evil as it is, it doesn't really evolve very much. It sits tight. The mutations are innocent, for as best we can see, and they're slow. So it turns out the structure is very amenable to a vaccine. And as you know, there's many trials, even one now going into phase 3, and it is possible in the early part of next year, which would be beyond any record in humankind, to have an effective and safe vaccine. So sometime, I would guess, in the first half of next year, we'll see a vaccine. It probably will require yearly repeat injections, perhaps even more frequently. And then the question that we have is, can we override the anti-vaxxer issues in this country, which are somewhat apart from the rest of the world? We have a very strong, through social media, anti-vax movement. We have to get 70% or 80% of the population vaccinated to start to get artificial herd immunity, if you will, because we're sure never going to get it naturally. We're at 4% now, and look how many deaths we've seen already, and all the other issues that we've seen. So I think we'll get out of it, but the vaccine is going to be the ultimate way. But, before that, later this year, besides the fact that the dexamethasone looked like it helps people on a ventilator, besides the fact that remdesivir helps some people, in terms of recovery from the hit in the hospital, we'll see other drugs that will help in modulating different phases of this illness. And then the neutralizing antibodies that are now in clinical trials is temporally, that's like having a vaccine, because you now have potent, and they can be multi-structural, taking down the virus at many different epitopes. So I'm optimistic that we'll see the fatality rate drop considerably over the months ahead, and the vaccine will kick in. And then someday with the home testing, where, you're going into your place of work and you already have your home test at home that day. It's on your phone, so it's authenticated. It's Abraham, and it's got your barcode. And when you go in, you don't have to do anything. You just basically show your QR code, and you're good to go. So I think the home testing is going to be essential, getting back towards normal in the months ahead. So I'm optimistic, but it's just that we have to be patient. And unfortunately, right now, the states that have been opening prematurely with no testing, tracing, isolation infrastructure, and even at times opening when their cases were not at all being leveled down. These are bad experiments to see that, it's lack of patience. And I understand people don't want to be locked down and they want to get the economy back. But, if we just look how much we're learning every day towards better treatments and better ways to mitigate. So we have to be patient to go the distance here. And I still haven't given up hope at all.
That's wonderful. I mean, I'm reminded of a line from Camus' The Plague, where he talks about as many plagues and pestilences there have been in history, everybody's always surprised when a plague arrives. And if you read the book, it just seems like we have to relearn the lessons with every plague. No one ever seems to carry the wisdom from the previous one very much further. But I've heard some great ideas today, Eric, especially like the idea of why can't we, as a federal program, employ more people who are unemployed right now as contact tracers? That would be a very valuable function to combine with testing. Otherwise, testing by itself does very little.
Yeah,
and
exactly.
I'm excited by the optimism I'm hearing in terms of the science and the way it develops. And thank you for taking the time to go over all these things with us. I'd love to get another update in a few weeks, because that's how fast this thing is moving. So I'm sure we'll have new things to talk about in a very short time.
Oh, thanks, Abraham. It's always great to have any conversation with you. And especially, I think it's great that you've brought out how the science is marching along at high velocity. That's something that we're good at. We weren't so good at preventing the pandemic landing in this country, but the science community has come together worldwide like never before. And in fact, switching into COVID gear from other areas, whether it's life science and social science and whatever. And so I think that cohesive solidarity within the science community is terrific, and hopefully that's going to be enduring, not just through this pandemic, but long thereafter. Thank you.
Well, thank you all for joining us for this episode of Medicine and the Machine. We look forward to your reactions, your comments, and I look forward to chatting with my co-host, Eric, one more time very soon.
And that concludes this episode of Medicine and the Machine. Remember, there is a transcript available of this episode on our website. Medicine and the Machine is hosted by Dr. Eric Topol and Dr. Abraham Verghese. Our executive producer is editor Robbie Atuma, and all of our podcasts are produced by Medscape Vice President Dr. Ivan Aransky. I'm Nick Andrews, and this is Medicine and the Machine by Medscape.